Hi everyone. Today we have Professor Nandan with us, who is a faculty member of Department of Management Studies and a core member of Robert Bosch Center for Data Science and AI at IIT Madras. He earned his PhD from Engineering Systems Division at MIT. His research and work experience is in the area of data science. Welcome, Professor. Professor, we hear a lot about AI today. AI is there in almost all industries and in all applications. How much of it you think is a buzzword?
So, in a sense, I do think it's a valid question, and but I don't think we're going to see the same phenomena occurring again. I don't think it's going to go out the same way it did back in the 1970s or so. And the reason I think there are a couple of reasons for that, at least a couple of perspectives that I have. One of them being that the digital ecosystem is very different between now and then, right? When I say ecosystem, I'm talking about how many things are happening on a digital platform. So you take something like commerce and e-commerce, you take human-human interaction, put it onto the social network platform, the way finance is being conducted and so on. So I mean, there's the very obvious thing of the digitization of the whole world, and artificial intelligence lives on that, right? Because you have the IoT and things being digitized, connected, controlled, monitored, and therefore the scope for artificial intelligence, the scope for using a kind of machine intelligence to make things better is substantially different now than before. The other obvious difference is also on the compute, right? So in terms of hardware and in terms of storage, computational power and so on, it's a very different world. So if you're going to think of this as a form of machine intelligence, we have the machines now are so different from the machines before. So just in terms of what can be achieved, it's very different. So I think the fact that the ecosystem is so different means AI is probably poised to do a lot more of what it promised than before, right? The other thing to also kind of keep in mind is that the way people were probably using the word AI back then was very different than how it's kind of getting used now, right? So back then it was far more of a theoretical idea, theoretical concept in computer science and math, closer to an academic subject, right, with a lot of promise. And for many traditionalists that is still the AI, but now when I hear the word AI, sometimes partly because it's become a buzzword, and that's semantics, that's fine, I'm not judging it. Especially in industry, pretty much I would say things that are in the data analytics spectrum, or in expert systems or decision support systems, or even broadly what you would call data driven decision making, gets combined into this word AI, and that's fine, that's again semantics, but we should kind of understand that these things are ingrained in the business, like these are tenets of rational decision making, and that's not going to obviously go anywhere. And so in that sense, I just don't see AI kind of disappearing. Maybe we'll choose different words. Maybe we will stop thinking of it as a panacea for everything, and perhaps get a little more realistic given its potential. But I don't see it disappearing in a sense.
Thanks, Professor. You've been instrumental in GAVS' offerings using reinforced learning. Can you please elaborate a little?
Sure. So let me break that into two parts, right? So let me just talk a little bit about what is RL, or reinforcement learning, for our viewers, and then I'll speak about why I think it holds promise in IT specifically. I think it holds promise in a lot of things, but I'll speak specifically about GAVS. So reinforcement learning is this area in machine learning which tries to solve the problem of control, right, as opposed to the more traditional forms like supervised learning and unsupervised learning. You can think of them as solving a learning problem. So what do I mean by learning and control? Well, when you think of it as a learning problem, you're dealing with a data set, and from that data set you're either trying to gather some insight about the data, or you're trying to use that data set to make a prediction. So this is broadly the learning problem that unsupervised learning or supervised learning seeks to achieve. Whereas RL is dealing with the problem of control as opposed to just the learning component. And by control, what we mean is typically you have the notion of an agent. This is typically a software agent. That's the artificial intelligence here. A software agent seeks to make a series of actions or decisions. So that's the control part, right? Where the agent is in an autonomous way making actions, and I'm using the word actions, control, and decisions in a fairly synonymous way, because depending on the application you will see which one kind of makes sense. It is seeking to make a series of actions and has in a given environment, so it's aware of the environment it's in, we call that a state, so the state it's in, and it makes actions, and the actions translate to some form of reward or punishment, right? And that notion is passed back to the agent. So here the agent is going ahead and trying to make these actions in different states in order to kind of maximize some notion of cumulative reward that it's getting. And so you can obviously see why this abstraction is more like than the learning problem itself. In a sense, I feel like the way you think about it, there has to be some learning. If you want to control something, you need to learn about it. But the end goal is not the explicit learning. The end goal is proper control or proper decision making. And the learning is in some sense under the hood, right? So it can be a naive form of learning, just as much as like keeping a count of every time I took this action, this was the reward I got. So some notion of memory is learning, or it can be something substantially more complicated, like an artificial neural network that's under the hood. But these are fundamentally different. And just so that this is not all in an abstract space of action, reward, and so on, you can think of various applications. So something simple like, how does a robot arm, how do you control a robot's arm, is a control problem. It's not just a learning problem. Obviously the robot needs to learn about environments, where the fingers are currently, and so on. So there's that part of it. But the goal is not just to stop that, the goal is to effectively control. So ranging from autonomous driving to great success stories from Google DeepMind on successfully playing chess and so on, AlphaZero and so on. We're seeing a lot of applications of RL. It's one of the more exciting fields. Okay. There was another part to the question, which is how can you use RL effectively, and why I'm personally bullish about RL being used in IT in a sense. Is because IT has always been in this drive towards automation, right? A drive towards, I wouldn't say automation, but moving away from a rule-based way of doing things. So, and I feel like RL achieves that end to end. So when you think about it, the early thing, the first step towards automation was in a sense of saying nothing should be manual, you kind of automate it through a form of rules that IT systems process. Even something simple like, how is a ticket handled, to when do you throw out an alert, had a bunch of rules written out in software code, and that was being executed. That paradigm left when supervised and unsupervised learning came in, when machine learning first traditionally came in. That paradigm changed to who decides those rules and why are those rules the right rules? Can we be more data driven? And so what happened was you had systems where you wouldn't explicitly program the rules, but instead the rules were kind of learned. So you just had a structure for the rule, but as to how exactly you should behave was learned from data. So the machine intelligence there was the machine's ability to process the data, to learn from the data what the rules should be. So that was the first move towards this being automated, right? So in a sense, this was the first layer of automation, right? Where you move from rule-based to you move towards data-driven. But I feel that even that, in a sense, can be a misnomer, because you become data-driven, and the data is again throwing out some insight, or it's throwing out a prediction. But then what does a business do? It puts a set of rules on top of that based on the output of what you just received, right? With reinforcement learning, because you are integrating, where the output is no longer the prediction or the insight, the output is the action that the autonomous agent is taking, right? And so in a sense you're taking, it's like pushing that element of manual even further out. And you know, the old system is what you would call a decision support system or data driven decision making, right? Like where the decision making engine is again a rule based manual engine based on the predictions or insights from the learning. And yes, that was itself a huge drive in automation, but I feel that last mile now is if you have autonomous agents no longer looking to their manual bosses and saying here is the prediction, and the boss throws it out of the window or you know, takes a decision based off of that. Why not have the agent make actions, take decisions, control something, and just create the ecosystem of giving the feedback loop of whether it was successful or not, and that way you are walking the talk when you say I'm automating things or I have AI in my process. So that's why I think that's why I'm excited about reinforcement learning, and I'm really happy to have the opportunity to work with GAVS in looking to see how some of these can be applied in the real world.
Thank you so much, Professor. It was so insightful.
Thank you for the opportunity. I had fun doing this.